Hi everybody, this is Algebra 2, Lesson 11, and today's lesson is about addition of fractions. But we already learned how to add fractions back in like 5th or 6th grade, but we're going to be talking about addition of fractions that have variables in them. So we already know from our simple adding fractions with numbers that if we had 1/3 plus 1/3, we can just add them. We just add across the top and we get 2/3 because the denominators are the same. We also know that if we have denominators that are different, so like 1/2 plus 1/3, we have to find the least common least common denominator, which would be 6 in this case, and that would be 2/6, and that would be 3/6, and we would get 5/6. It's kind of the same thing with fractions with variables in them. So the first example, all of the denominators are going to be the same. So a over b plus 2 over b plus a plus 3 over b. So all of these denominators are the same. We can just add across the top and we'll just add like terms. So a plus a would be 2a, and then 2 plus 3 would be 5, and all that would be over b. Pretty simple. Now what if we have denominators that are not the same? So example 11.1 gives us k, actually I'm going to put it up here, k over 2a plus bc over ax squared minus m over ax to the third. Okay, so I have to come up with the least common multiple of all of these factors. So my factors are a and 2 and x squared and x to the third. That just means that I've got 3 x's in there. So that's what my new bottom has to be. A, 2, a, and then x to the third. And this is going to be the same for all of my terms. Okay, now I have to figure out what my tops are going to be. Alright, so to get 2ax to the third on this first one, okay, so I'm looking at that first one, I had to multiply 2a times x to the third. So I have to do the same to the top. Multiply that by x to the third. So I'm going to get k x to the third. Do the same thing with the next one. So this one has bc over ax squared, and I want the new bottom to be 2ax to the third. So what am I missing from here that I have in there? Well, I've already got the a, and I've already got 2 of the x's, but I don't have a 2, so I had to multiply it times 2 and another x to get 2ax to the third. So I have to do the same thing up here. I have to multiply this times 2x. So it would be 2bcx. Okay, now I'm going to have to do the same thing with this one. This one is m over x to the third. Oops. ax to the third. And I want it to be 2ax to the third. So what did I have to multiply it by? Just 2. So I'm going to have to multiply my top times 2. So I'm going to have 2m as my new top. Now I can add because all of my denominators are the same. So my new bottom's just going to be the same. And I'm going to have k x squared plus 2bcx minus 2m. I can't put any of these terms together because none of them are like terms. So that's my answer, is that right there. Alright, we'll try another one. This one is m over k minus b plus cx over ak squared. Now, when you have a whole number in there, the easiest thing to do is just turn that into a fraction. So it would be b over 1. Just put it over 1 and then you won't get confused. You got to make sure that you know that that fraction is in the numerator, not the denominator. Okay, so now we have to find a new denominator that has all the factors. So it's got k and a and k squared. So I think we can just go with ak squared as our new denominator. So ak squared now I have to go back and look at each one and see what I had to do to it to make it be ak squared. So on this one I had to multiply it by, see, to go from k to ak squared, we're missing, we need the a and we need another k to get us ak squared. So that means we have to put the a and the k up here and that m, that's already there. This one, the whole thing, all we had was 1. So 1 times ak squared is going to equal ak squared. So we're going to put a, and then we got to put the b in. Don't forget what's already on the top. And then the last one's already ak squared, so we didn't have to do anything to it to get it to that. So we can just leave it. That means we can leave the top. Since we didn't multiply the bottom times anything, we don't have to multiply the top times anything. Alright, so our answer is going to be ak squared as our denominator, and then our top is going to be akm, see, there was a minus, there was a plus, minus abk squared plus cx. Alright, hopefully that made sense to everybody. That was just the first part of this lesson. The second part of the lesson is completely different. Alright, so the second part is talking about inscribed angles. What is an inscribed angle? An inscribed angle is an angle whose sides are inside the circle and whose vertex is on the circle. Okay, so let's demonstrate what that means. So I've got a circle, okay, and I have an angle, and its sides are inside the circle and its vertex is on the circle. So there's its vertex, and here's two sides, and they're inside the circle. That's an inscribed angle. Now, it's telling us that the measure of the vertex is half the measure of the arc. So its arc is going to be from here to here, and the measure of the vertex will be here. So this is vertex, and this part is the arc. Now, if the measure of the vertex is half the measure of the arc, that means if this is 22, then this one's going to be double that, 44. So when you go from one side of the circle to the other side of the circle, it doubles. We've looked at circles before where we had one going like this, and if this is 44, then this is 44. This is if you take that same angle and you take it all the way out to here, this is going to be half of that. Alright, the measure of the vertex is half the measure of the arc. so let's do a problem that is an example here. So we've got a circle, and it has one line running across like this, and then it's got another line going like that, and then it tells us that from here to here, and then it divides it up from there to there. So that is a distance, that is a distance. Okay, so it's all the stuff that's not part of this arc. And then it tells us that this is 40 degrees. And then it tells us this bottom part here is 7x plus 40. And this top part is 5x. Well, if we know this is 40, then we know that this is 80. Okay, so our arc right here from there to there is going to be 80. We also know that this is half of the circle, so that's probably going to be 180 right there. But we're gonna make sure. So we're gonna add up 80 plus this, and how much is all the way around a circle? 360. So we're gonna say 80 plus 5x plus 7x plus 40 equals 360, because that's a whole circle. All the way around the whole thing's 360. Alright, so we're going to add like terms. So we will get 40, 8 and 4 is 12, so 120 plus 12x equals 360. Now we're going to subtract 120. And we're going to get 12x equals 240, and then we're going to divide by 12, and we're going to get x equals 20. Alright, now let's see if it was 180 from there to there. If this is the diameter, then it would have to be 180 from there to there, because that would be half the circle. So if we said 7 times 20 plus 40, what are we going to get? 140 plus 40, and that would be 180. So yes, that is half the circle. Alright, let's try another one. Well, they don't have another example. So go ahead and pause the video and do the practice problems, and then I'll come back on and work them for you. Alright, so hopefully you guys have worked the practice problems. The first one is A here, and it says m over 3b plus ak over bz to the fourth, to the third, minus y over bz to the fourth. Okay, so we're going to look at all these, and we know that we're going to need 3, and we're going to need b, and we're going to need z to the fourth. Okay, so our new bottom is going to be 3bz to the fourth, and each one is going to have it. Now we got to figure out what our new top is. So for this one, we didn't have to multiply by 3 or b. So 3 and b, we just multiplied by z to the fourth. So we're going to get mz to the fourth. This next one already had a b and already had 3 of the z's. So, but it did not have the 3. So 3bz to the fourth, it's already got b and z to the third. Don't need those, and we don't need 3 of those, so we only have 1 left, so that would be 3z. Okay, so we're just have to say a, let's do the 3 first. 3 A, K, Z. Okay, next one. We've got 3BZ to the 4th. And here we have BZ to the 4th. So really what that means is 3 times B times 4 Z's. And what do we already have? We already have a B and 4 Z's. So some of these we can get rid of because we've already got it. So that means we only have to multiply times the 3. Okay? Now we're just going to add these together, and none of them are like terms. So our new bottom is going to be 3BZ to the 4th, MZ to the 4th, plus 3AKZ minus 3Y. And that is the answer. Alright, B has Z over B minus K plus 2MN over AB to the 3rd. Okay, so first thing I'm going to do is I'm going to put this K over 1 so we don't get confused. Alright, so this one, our new bottom is going to be AB to the 3rd. Now I got to figure out our new tops. Here we just multiplied by one of those B's. So we're still going to have the A and 2B, so B squared and a Z. This one, it was the whole thing, so A, B to the 3rd, and K. And then this one, A, B to the 3rd, A, B to the 3rd, we just leave it the same. Alright, so our new bottom is A, B to the 3rd. And then we're going to add all these up, so A, B squared, Z, minus A, B to the 3rd, K, plus 2MN. Alright, there's that one. Okay, so for C, I'm going to have to erase all this. For C, we have one of these inscribed angle problems. Okay, so it's got a circle with what looks like a diameter right there. And then that one's going right there. Alright, and it has some distances marked, so we're going to say from here to here is labeled as 5x plus 80, and then from here to here is labeled as 4x plus 20. And then it tells us this is 40 degrees in here. Alright, and then it says find y, and y is this distance right here from there to there. Oh, we're supposed to find x and y. Well, y is pretty easy because we know it's double what 40 is, so y is 80. We can figure that out really quickly. Alright, so now we have to figure out what x is. So we're going to add up all of these, and then we're going to set them equal to 360 because all the way around is 360. So we're going to have 4x plus 20 plus 5x plus 80 plus another 80 right there. So I've got my, I'll show you these. 4x plus 20 right here is this one. And then 5x plus 80 right there. Okay. And then the last one is this 80 right here. Okay, so we're just going to add all those up and set them. We're going to set that equal to 360. Okay, so we're going to add like terms first. So we've got 20 and 80 and 80, which would be 180. Then we got 5x and 4x, which would be 9x. Alright, so now we're going to have to subtract 180. And that's going to be 180. 9x equals 180, and then we divide by 9. And x would equal 20. So x equals 20. Now, do we know if this was half? Was that an exact diameter? Well, if we said 5x plus 80 equals 180, let's see if it works. 5x equals 100. So x equals 20, same as we already have. So x is 20 degrees and y is 80 degrees on that one. Okay, so your homework, your Wednesday homework, which you don't have to actually turn in on Wednesday, but I want you to do it by then. We're not having class on Wednesday. We've moved fall break, so we're having fall break next week. So no class on Wednesday, but you still need to do this Monday math lesson. Please don't wait until we come back from fall break to do it, because you're going to forget what you're doing. I guess you can always come back and look at the video. So this will be due on not this coming Wednesday, but the next Wednesday, which I think is the 23rd. And it's going to be lesson 11. So your homework is lesson 11. Alright guys, I will see you soon. And if you have any problems, just call me, okay? Or text me, or email me, or messenger me. Bye.